What is C++? When you save the file, you're gonna save a file .cpp. That's how the compiler or the application interface knows that you are creating a C++ code. Okay, what is C++? C++ is a modification of C and sometimes called C with classes. Was developed by a Danish professor called Jarn Stroustrup. I'm not sure how to pronounce this. Stroustrup, I think, in the late 60s, and it was based on C, and is today, 2021, still one of the 5 most popular languages, even though it's one of the first languages to be established. So C++ is used all the way from applications such as internet browsers to operative systems such as Windows. Windows is based on C++, and firmware. Linux, Mac, and Windows, all of them support C++. In fact, Linux and Mac have very easy way to run your C++ code through something called the terminal. In Windows, we use APIs or application program interface, and we use something called Visual Studio, which is something that we're not using for this class because it's a little too much to install and it's a little too advanced to handle. So instead, we're gonna use dev++, dev++. So in Windows, it's still pretty easy to run your C++ code. I forgot to mention here that depending on what applications you want to use, you choose your operative system. So for instance, if you're going to be working on networks, you probably want to use a Linux cluster. If you're just going to have personal computers, you're going to use Windows or Mac, or even a computer or laptop with Linux installation. If you are going to use C++ for your own projects, homeworks, research, you can use a free version of Visual Studio. But if you have a company at some point and you're going to use C++ or any other language really to develop applications and sell, you probably have to look at version that you would have to pay for it. One, for support, and also because I guess those are rules of business. So be careful when you start making money if you work on programming, which API do you have to use. So as we said before, applications, we have business and web applications. C++ is the language used for Microsoft Office and Windows, for QuickBooks, and many other applications. For graphics and applications for design such as Adobe, and web browsers. Web browsers are also designed based on C++ language, and even Python. Python is created based on C++. So the parts of C++ are that in around 1969, the C language was established. And C language came because first language called A was created, but it was not standardized. So a language called B was created based on A foundation, but it was not robust enough. So finally, the language that we know as C was created, and that was standard. By 1972, C was complete standard language by ASCII, or A is or sometimes referred as ASCII C standard. And in 1979, C++ was created, and then there are other derivations. So now, for instance, in 2000, the D language was created. And of course, there are many other languages that are out there, Java, Fortran, etc. C++ is based on the C preprocessor. So remember that when you create a code of C++ code, you have to use the preprocessor, the compiler, and the linker to be able to execute your code. Well, C++ uses the C preprocessor to organize your code underneath. Is based on classes and objects, as we saw before, because it's object-oriented. Uses templates, which is a pretty nice and advanced way to deal with objects. And uses the standard template library, which we'll go over later. C++ has different versions, C++ 98 and C++03, and these are standards, the ISO standard. That's why C++ became so, that's one reason why C++ became so common, is because it was standardized so that everybody using C++ could use. What does standardized mean? So if you have an IBM or an HP computer, both hardware and structure could run your code, versus before that, the code was depending on the hardware that you use. In fact, by now you know that if you go to your folder, you'll find your x86 architecture, and processors decided, or manufacturers for processors decided to agree on a common architecture for programs to be able to run on. So this is part of this, where 98 and 03 are I would say one of the first standardized C++ languages. Then became C++ 11 in August of 2011, had major extensions and range functions. So this was a huge step towards advancing C++. And C++ 14, which is December 2014, was a refinement of C++ 11. And C++ 17, which came in December 2017, was a much better, more robust C++ language, and that's the one that it usually installed in most applications. So when you run your C++ code, you're probably using your C++ 17. So when you get errors, make sure that you know what C++ version you're finding the answers or the errors for, because some syntax and some errors could be different. Some tips for C++ programming are, first of all, understand the syntax. Just as any language, as English or Italian, Russian, Spanish, you have to understand the syntax. So if you don't know the kanji alphabet or the kanji writing scheme, it's pretty tough to understand written Japanese, for instance. Or if you don't know the Latin alphabet, I don't know if you would be able to understand English or read or write English. The same thing with languages. It's important to understand the syntax first of all, and that's the very first thing that we'll do. Then it's important to understand the data types, operators, and functions. So data types is if you're dealing with numbers versus names or letters. The operators, is it math function? Is it database that you want to manipulate? And functions. Functions or methods are one of the most powerful options, or are one of the most powerful solutions that computer programming offers. And this is because you can perform actions in an organized manner and repeat the action several times for different parameters. So for instance, if your function is to divide a number, it does not matter what number you input as long as you input a number. So if you don't input a number, the function will not work. Once you input a number, you will have division. And that is very powerful because functions can be pretty complicated. You can multiply two matrices, or you can divide a system of equations by a number. So functions could get pretty complicated or pretty easy, and it's up to the programmer to design what parameters and what functions are going to be implemented for the code. Classes and objects. This is perhaps the most powerful part of C++ programming. Well, I guess also templates and STL, but classes and objects is really the basic concept behind object-oriented programming. And this is building all the structure of your program. So we're going to go through this later on. Templates is excellent, as we mentioned, to deal with data, and the standard template library, which makes very easy to access some functions built in for C++. These are some common errors that that you will find for C++ programmers, mostly when you're new to C++. When you deal with objects, common objects can be numbers, could be strings of data, could be, let's say those two for now, but could be arrays, right? So it is very important to know what type of number you're dealing with. So when we talk about numbers, evidently you have positive and negative and 0. You can have -4, but you can also have a -3.5. And same here, you can have a +5 or a +7.1. In C++, the negative and positive numbers are called signed or unsigned. So this is important because C++ has a very organized management of memory. So when you have 1 byte, which is 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. Good. So we have 2 to the 0, 2 to the 1, 2, 3, 4, 5, 6, 7, which is the same as 1, 2, 4, 8, 16, 32, 64, 128 bits. Okay. So these are the possible combinations that you can have with zeros and ones. Okay. All right. So when you have an unsigned number means that, or unsigned data type, means that all these memory portions would have some type of data. So you start here with a 1, 0, 0, 1, 0, 1, 0, 1, and this is a number. But when you talk about signed data types, this first memory allocation portion is reserved for the sign. So 0 would be positive and 1 would be negative. And the rest, or the other 64 possibilities, are reserved for the number or for the combination of 1 and 0s to allocate your memory. But that's not it. Also notice that this number is a whole number, same as this. These two numbers are called ints or integers. And these two numbers are not ints, are something else. They could be either float or they could be something called double. Okay, so we're going to talk about this in more detail. For now, just want to mention that one of the most common errors is not knowing what type of data types you're dealing with, if it's an int or a float or a double, because in C++, if you have 3 plus, that's a 3, sorry. If you have 3 plus 4.2, this is a very basic operation. This is just 7.2 for us. We don't even need to use a calculator or anything for this simple operation. For C++, this will not run, will give you an error, because this is an int and this is a float. So what you need to do is, if you're going to do this type of calculations in your program, beforehand, you have to say that, okay, so this is going to be a float or a double, and it's going to be, for instance, you would define it as float equal, say, a, and a equals 3.0. So now that is a float, and 3.0 plus 4.2 is possible now. Another option is that you can have 3 as an int and 4.2 as a double, but when you do this operation, you cast your int, or say, cast my int to a double to perform this operation. So you might wonder, why would you have a program that has int and not always have double? The answer is because a double or a float is twice or even 4 times has more memory to use, or occupies more memory, and sometimes you want your program, your script, to be very lean, very fast. And also because sometimes you only need int. If you're dealing with paper clips or cars, you're not really expecting to use 3/4 of a paper clip for an order. So sometimes int is enough, but nonetheless, this is a very common error when you combine data types. Another very common error is when you have strings of numbers. So when you read a number from a file, and when you read a number from your ASCII table or a file, the text file, this is a string. You have to cast this to a number, int or float or whatever. So those are common errors. And another one is that if you're using a number that is not declared, you're basically gonna say it's not declared in the scope. So you have to go ahead and declare. And we'll talk about this in a future lesson, that every variable that you use in your code has to be declared before. A very common error, the second most common error in my mind, is not adding the semicolon at the end of each line. In C++, every single time you write an instruction, you have to add the semicolon at the end. If not, you're going to have unexpected error. And sometimes you think it's something much more advanced, where you start changing your code, not realizing that you just didn't put a semicolon at the end of a line. Permission denied is a very common error for Windows applications mostly, and it's because the program is already running and you want it to compile it and run it again. So if your program has already been executed and you try to run it again, you're gonna have some type of error. So make sure, if you get this error, to shut your execution windows or your program execution streams. I'll show you when we have our first program running. but make sure that you're not running another version of the program so that you don't have this error. And somewhat common error is the segmentation fault error. And this is basically when you're dealing with a vector, say for instance that has 3 positions, and you're using a loop to rewrite or to read the rows. And say your loop goes over one more iteration, so goes to a 4th element, but the array only has 3 elements, or the vector only has 3 positions. So if it tries to get to a different or more, if it tries to get to another position that is not inside a vector, that doesn't exist, that means that it's trying to allocate a place in memory that is not part of the vector, and that will give you a segmentation fault error. In order to run a C++ code, you must have what is called the headers and libraries. And this is because when you run a code, you want to have access to simple operations like summation, subtraction, multiplication, division. You want to be able to print something to your screen. You want to be able to write or read from a file. So all these things, somebody already made them possible for the architecture of your machine or for your computer, and those things are saved in the headers and libraries that you just have to call for different operations. So for instance, for the print standard, you just have to access the input-output standard library, which is not here, but we'll see it in an example. And when you want to use standard templates from C, you're gonna have to call the standard C library. Or communicating with inputs and outputs from other programs, you're gonna have to use the environment to make sure that your program starts and finishes with no errors, and so on and so forth. We'll see different libraries that you'll definitely need to access some of the functions that you probably will have to use for your code. So this is very versatile, and in terms of you don't want to load a bunch of headers that you don't need if you're not going to use them at all. So ideally, you only call the ones that you're going to end up using. A very common one is the using the namespace, and that one is because you want to use functions without having to call the structure of the namespace every time. If this is confusing right now, let's wait for an example and you'll see how easy it is to understand this part. But for now, just understand the namespace is designed to provide additional information to differentiate the functions and the classes and the variables. So for instance, in a class, we have 2 Marys. And we met them for the first time. Kind of like the code that you're writing, the compiler sees for the very first time the information that you're providing. So we're gonna need something else to know which Mary is who. So maybe last name, or if they want to be called by a nickname. So the same thing is for the namespace. Is basically providing more information for the 2 variables that are called. For example, this is just an example. 2 variables that have the same name, so that they can be differentiated. So we're starting to talk about the C++ syntax. So as we said before, we're going to use the header for the standard library. And every C++ code is going to have at least one header, because either you're going to print, or you're going to write, or you're going to read, or you're going to do an operation that requires summation. So for instance, the return, the puts, this is another way of printing. These functions are found in the CSD DIO, the standard library. And if we go to dev++, which you should be installing, or you should have installed by now, you simply say new file. Here we're going to see this example. So right now it's not saved as anything, and it's okay. You can save it now or save it before you run it. And we're basically gonna reproduce this code. So we're gonna include the header, which include when you have the hashtag include and you execute it, or sorry, when you compile it, the preprocessor will know that this is a header. So that's where the preprocessor comes into place. And we're gonna say that we're gonna call a library called the CS standard library. And we have our first library called, and that is so that we can access some basic functionalities such as print to screen. And this is the very first code that most programming languages will advise or ask you to do, because back in the 60s and 70s, when programmers were designing languages, the computer that they had wasn't necessarily connected to a screen. Screens were very rare. What they had was a CPU, a keyboard, and a printer, so that when they wanted to check if their code was working, they would type print or put or some type of function that would let them see what the code was doing. So that's why print is one of the basic operations that any code, any language will have by default. And that is going to be what we're going to do now. We're going to print a single line, assuming that we're connecting to a printer, and we're just going to say, show me what I'm creating here. So in order to create a C++ code, or a C code as well, you have to have this block. This is a must. This is something that you'll have to remember. And what this is this saying that we're going to create a main function that is going to return a 0, or a successful operation, if there are no compilation and we don't find any execution errors. C++ is going to return a 0 to memory, and it's going to say, and that basically means that it's successful in running. So now anything that you want to do in your code will be in between lines 3 and 5. The whole Windows 10 operating system, or the whole Microsoft Office suite, everything will be between the lines 3 and 5. This is the main structure of a C++ code. Anything that you want to do in your code will be between lines 3 and 5. As I said, Windows operating system is this fashion as well, just that is thousands and thousands of lines, versus now we're only going to have a few. So let's go ahead and say puts, which is a function. Hello world. So you can use tab or space, or you can leave it like that. I like to have tab to indent my code and make sure that I can later find my main functions, because you can have other functions that are not the main function. All right, so this is the very first code, and if you want to run it, you come here and say compile, or press F9, and then it's going to ask us to save it. So we're going to say week 1, code 1. All right, so as I was saying, this is expecting a semicolon. So that's the first error that I made. Recompile. No compilation errors. So now I could have an execution error. Hopefully not, but execution errors are the ones that, for instance, segmentation fault, or when you're trying to access a place in memory that doesn't exist. But I'm not trying to do anything crazy like that. Right now, I just want to print something. And there you have it. It's printing hello world, and it's creating a new window. This is called the command or terminal window, and it's printing hello world. So at the end, it will tell you how long it took, and that it returns a 0, which is successful. So this is the very first code that we created. So as we said before, each line of code will execute sequentially. So you can create new lines as long as they're before the return 0. This is the very last line, and then you close your program with this open right side bracket. But each line has to be sequential. So your logic has to be sequential like that. And semicolon is a very important aspect of the code. If you don't have semicolon after each instruction, it will not run. The main function, this one, is called by the operative system, by the OS. And this is what is going to be executed. Every other function is called from the main function. So you can have other functions that say ask for age, how old are you, or any other function is going to be declared after or before the main function. But in order to run, the functions have to be called from the main function. They have to be added to the main function. This example uses only one function, which is the main function, and every C++ code has at least one function, which will be the main function. There's something called identifiers, and identifiers is what we use to create the code. So the ISO, or the standard identifiers for C++, and I guess every language is, or every programming language, are Latin alphabets. So it's going to be the capital and lowercase letters, so that you can create your variables. So like, for instance, my underscore var will be something like called my variable, or cost. You can name your variable whatever you want. There are some nice to have, or some rules of thumb on when to have lowercase versus uppercase, or when to have underscore. But for now, I'm not going to worry about that. I'm just going to let you create your variables in a way that you can consistently remember. But when you start to create larger code, hopefully you'll have a method where all your variables are in lowercase, except for, say, if they are matrices, they have start with that. If they are vectors, they start with an uppercase. You can design your own program however you want it. Also, you can have numbers in your variable identifier. So you can have my variable 0, or you can have my cost /1. Okay, but it's not equivalent to have capital A lowercase z and lowercase a capital Z. These are going to be two different identifications for a variable. To provide identification to variables, it's important to have a correct combination of all of these rules. So, for instance, if you start with a dash underscore and then variable and then underscore, that will create an error or potentially create an error because those type of declarations like that are already used for internal purposes in the code. So you probably don't want to create your variables starting with lowercase with underscore. Also, there are some reserved names that you probably don't want to use, and the list is quite extensive. So you probably have to look that up at some point when you start creating your code. But just some of the most common ones are: do not name a variable continue because that's already allocated for a function in C++ where you can write continue if you want your code to jump to a different line. Don't default. Don't name your variable default. This is already assigned for C++ uses. Delete is already do and double are already assigned for C++ operations. Else, enum, char, break, bool, auto. So as I said, those will not be available for you to use as naming your variables. But you're probably gonna get an error anyways if you try to use them. And how long can I get my identifiers to be? So the rule of thumb is less than 63 characters. And that is something like this. That is this identifier is a very lengthy 63 character long. And notice that when you declare your variable, you want to have underscore or just remember to avoid if you're not going to have an underscore underneath, then for example say my and capital V var. Anything that you want to do to avoid having a space. My space var will not work. You cannot have spaces when you design your var. Or when you're saying name John Smith, this space is not allowable. So you're gonna have to have either underscore or just no space whatsoever. And as we said before, this underscore before the name is reserved for system variables. So the takeaway is try to keep your identifiers or the name of your variables as short as possible, but with enough information that you can or somebody else can open the script and know what the variable means.